Shri Sai Ram. Today we are going to see a new lesson, Trigonometry from class 10 Mathematics. I think this is the first time you are hearing this word trigonometry. Okay, so before going into this trigonometry, let us have a look at a situation every day or once in a while in your lifetime, in our lifetime, we will see. Okay, let us think that three friends are there and they are about to meet in one place. Okay, two friends already there. The last one is running and reaching there. At the time, one of the friend is asking, "Oh boy, what in your shirt? So where you fell?" And another boy is telling, no, he wouldn't have failed. He would have played without us. That is why his shirt is full of mud. That is like the other person is telling. But the boy who was running and coming in the third, he was telling that, no, I was not playing and also I was not failed. I was helping a man in his garden to help his dog to come out of the mud. That is why my shirt became mud. Okay. In this, I'm not telling that the same situation we will be facing, but someday or somehow everyone will have faced this situation. Is it right? So from this, what we understood? So each person's view of angle, that is point of view, will be different. Is it right? So why I am telling this situation while I am starting this trigonometry? Let us see in the class. If you guessed means you are very perfect in this trigonometry. Let us see. So today's topic will be trigonometry. In this we are going to see introduction of trigonometry. Our topics will be introduction, trigonometric ratios, relation between ratios and some solvables. If you are very thorough with these basics, it will be very easy to solve, I think. Next. Assignments, every time we will give, that's only. So next, trigonometry. Let us see. Trigonometry, as the name might suggest, is all about triangles. So in this name itself, you can see tri. That means tri side or triangle. From the name itself, it is telling that it is all about going to talk about triangles. But we have too many types of triangles. Let us see. More specifically, the trigonometry is about right angled, where one of the internal angle is 90. Okay, so we are going to see about triangles, particularly about the triangle whose one of the internal angle is 90. Till now, you will be thinking that if it is a right angled triangle, that means if one of the internal angle is 90, only one person will come and stand. Who is that? Pythagoras theorem. But now, from now onwards, you have to think about the trigonometry also. Trigonometry is a system that helps us to work out missing sides or angles in a triangle. That means if I have a triangle, if I have two sides, how to find the third side? If I have two angles, how to find the third? What is the relation between these three sides? That and all we are going to see here. It's a word about trigonometry. There is perhaps nothing which so occupies the middle position of the mathematics as trigonometry. Why he told like that? Because our basic shape is triangle. Is it right? Within two lines, we cannot make a closed polygon. Is it right? So, triangle is the basic polygon. Using this triangle, I can make a 4-side, 5-side, 6-side, everything. So, if I connect more triangles, I can increase the sides of the polygon. Is it right? So, if I am able to understand the basics of characteristics, everything of the triangle, then I'll be able to explore for the more sides. Is it right? So, that is what we are going to. That is why they told this. They told that trigonometry is the middle of the portion of the mathematics. Next. The word trigonometry is derived from Greek. So what is that? In fact, trigonometry means is the study of relationships between the sides and angles of a triangle. Trigonometry means the study of relationship between the side and the angle. Okay, now you understood what we are going to see here. That means if I have an angle, how I am going to connect that angle with the sides. Okay, now trigonometry. Trigonometry, it came from Greek. From the word itself, we can tell what is it. Tri, three, gon, side, metron, measurement. That means we are going to study about three side measurement on the basis of the angles. Next, trigonometric ratio of the angle. A study on some ratios of the side of a right angle with respect to its acute angles. This is what you have to concentrate on. A study on some ratios of the sides of right triangle. Already we told that trigonometry particularly is about the triangle which have a one angle as 90 degree with respect to its acute angle. That means right angled triangle is there means if one angle is 90, then the other two angle will be less than 90, right? That is what it's telling. A study on some ratios of the sides. I'm going to talk about these sides of a right angle triangle with respect to the acute angle. Okay. Now, let us see. Next, these ratios can be extended to other angles also. So, if I am talking, next question, do I have to talk only about the acute angle? No, you can extend it, but not in this year. Okay. We will also define the trigonometric ratios for angles of measure 0 and 90. We are not going to talk only talk about the angles, that means to 15, 30, 45, 60 like that. We are going to see about 0 and 90 also. So let us see. Let us see some examples from our surroundings where right angles can be imagined to be formed. That means only if I draw a right angle, I will get a right angle. No, wherever you are in your surrounding, you can see a right angle triangle. Just one example. So we calculate from that. From that we can calculate the trigonometric ratios and also the trigonometric identities. So let us see the example. In one of our campus, we have Annapurna temple just before entering place. Just enter into the gate, you can see the Annapurna temple. Just right opposite to that Annapurna temple, we have our school campus with a clock on the top. I think you can see the clock on the top. Okay. Let us think that we are standing inside the temple and we are looking at the clock. Let us see how it will be. That means I am standing inside before the temple and I am looking at the clock. Right? Imagine that I am standing before the clock and I am just moving up my chin and I am looking at the angle. That means higher angle. I am looking at the clock. Right? If I am bringing these to my trigonometry, how it will be from the side view? That means if I am standing here, I am looking at the top. Let us see. This is the temple. I am standing here. I am looking at the clock. Right? The person who is standing away from you, how he will see, how she will or he will see. That means this is a straight line and ground is straight and you are looking at an angle. Right? Can you see the 90 degree here? This is also reversible. If you are standing in the clock room and you are watching the temple, both sides of you are possible. Right? So this is possible whenever you are one person standing up in the building and one person standing down in the ground. You can see a right angle triangle, is it right? Or in the hill, temple on the hill, or tip of the tree, and you are standing in the ground. At that time also you can imagine a right angled triangle. Is it right? So wherever you are seeing a tip of a tree or a building or whatever, or else you can see a tall man. Think that LKG boy is seeing a college boy, he will be seeing like that. That is also creates a right angle. Is it right or not? So surrounding us, too many right angles are there. So on that we are going to learn something. Let us see. Let us take right angle ABC on the point of view from the angle A. That means imagine the temple, building, clock and everything. Put it in a right angle. Put it in a right angle. Now we are going to see something about view from, not from C, from angle A. From angle A. That means you are standing in the temple and you are watching the clock. Okay. Let us see. Side BC. Side BC, the opposite side of angle A. It's just a normal. This is angle A. Opposite to the angle A is opposite side. Next, side AC, hypotenuse. Why we call that as hypotenuse? Because already we know that the side which is opposite to the 90 degree is always a hypotenuse. Next, side AB, side adjacent to angle A. So we always use this word, the person who is opposite to me, the person who is adjacent to me, the same thing. The side which is adjacent to the angle A, that is called adjacent side. The side which is opposite to the angle A is called opposite side. Okay, now we are talking only about A angle, A angle, A angle. That means if when I am looking from the angle A, I should give some word, I should give some mathematical representation of that. I cannot tell angle A. Is it right or not? So that is what we are going to do next. After seeing this, let us take a right angle triangle ABC and now we are going to see from the clock. Okay. Previously we saw the whole diagram on the basis of that you are standing in the temple. Now we are going to climb up that building and we are going to stand in the clock room. So now what happens? Now BC becomes the adjacent side of the angle. Is it right? If you are standing in the clock room, who is the adjacent? BC, right? Next, side AC, the hypotenuse. Already we told about that. Next one, side AB, the side opposite to the angle C. You can see that who is opposite to angle C? AB. Okay. So that's all. Now I think you have a clear idea when and how you have to get the idea of the side. If you are standing in the temple, then AB is the adjacent side. If you are standing in the clock room, then BC is the adjacent side. Right? When our three friends met, one person said something about another friend said something else, right? From his point of view, he failed. From that friend's point of view, he played, right? Both are different. The same way, from this angle, AB is what? Adjacent. Next, from that point, BC is adjacent. Now, let us see the next. The trigonometric ratios of angle A in right angle triangle ABC. Till now we saw about only the angle about opposite to angle A, opposite to angle C. Right? Now we are going to include the everything in the world of trigonometry. So what I get? If I am talking about the opposite side of angle A, I will tell that angle as sine A. If I am talking about the opposite side of the angle A, then I will call that as sine A. Okay, next. So you can see opposite by hypotenuse. Sine of angle A. You have to read like that only. Sine of angle A or sine A is equal to opposite by hypotenuse. Opposite side of angle A by hypotenuse. Next one, cosine. That means when I am talking about my adjacent side, I am giving the angle A name as cosine. Cosine of angle A. Normally we call it as cos A. Cosine of angle A is equal to adjacent side by hypotenuse. Adjacent side by hypotenuse. Then the last one, tangent. Tangent of angle A. Normally we call this as tan A. Tangent of angle A is equal to opposite side of angle A by adjacent side. That means sine A is opposite by hypotenuse. Cos A is adjacent by hypotenuse. Tan A is opposite by adjacent. That means I am going to relate the opposite side with hypotenuse in the form of sine A. Next, adjacent side and hypotenuse in the form of cos A. Then I will relate the opposite side and adjacent side in the name of tan A. Okay, do you understand? So how to remember this? S-O-H. Soha. Next, C-A-H. Kaha. Next, T-O-A. Toa. So repeat it again and again. You will never forget this. Soha, koa, toa. Sorry, kaha, toa. Soha, kaha, toa. That's all. It will be easily you can remember this. Really, it is very, it's like playing. Really, it is like playing only. So let us see the next one. Cosecant. So why we saw about sine A, cos A, tan A, right? We are going to see the reciprocal of that also. Why we need that? If I have a number 2, I will have a reciprocal of that. Is it right? Is the value both are same? 2 is equal to 1 by 2? No, because 2 is 2, but 1 by 2 is 0.5. Is it right? Now I think you understand that if a number is there, its reciprocal value will be different. That is what we are going to see here. We know the value sine A. Then what will be the cosine? Reciprocal of sine A. That means we know the sine A. If we have a reciprocal of sine A, we have to give a new name for that. That is cosecant of A. For this you cannot use cos. It is called as cosec. Normally it is called as cosec because cosine is also there, cosecant is also there. Both are different. Cosecant is reciprocal of sine. Okay, so be clear with that. Next one, secant. Secant is the reciprocal of cosine. Here sec, S-E-C. Normally we call that as in a short form sec. Secant of angle A is equal to reciprocal of cosine A. Next, cotangent. Reciprocal of tan angle is equal to cotangent. We normally call it as cot. So we call this sine S-I-N-E as S-I-N. So never ever call it as sin because S-I-N sin. But in trigonometry, short form S-I-N is sine. Never call it as sin, please. Next, here cos, here tan. Okay, here cosec, sec, cot. I am repeating again. Sine, S-I-N-E, sine, but we represent that as S-I-N. Okay, sine, cos, tan, cosecant, cosec, sec, tangent. Okay, just now we saw that cosecant is a reciprocal of sine, secant is a reciprocal of cosine, cotangent is a reciprocal of tangent. Right, now we are going to see the direct values of cosecant, secant and cotangent. From where? From the triangle. So let us have the trigonometric ratios of angle A in the right angle triangle, but now we are not going to see the sine, cos and tan. We are going to see about cosec, sec and cosec, sec and cot. Okay. Now cosecant of angle A, that means reverse of reciprocal of sine. What is sine? Opposite by hypotenuse. So here it will be hypotenuse by opposite. Next, so you can see the arrow mark there where it shows. Next, secant of angle A. Who is secant? Secant is reciprocal of cos, right? Cos is adjacent side by hypotenuse. Now reciprocal of that is hypotenuse by adjacent. Secant of angle A is equal to hypotenuse by adjacent. Okay. Next, if you are very thorough with sine, cos and tan, this is and all very easy. Just reciprocal of that. Cotangent. Cotangent is reciprocal of tangent. Tangent is equal to opposite side by adjacent side. Its reciprocal. Cotangent of angle A is equal to adjacent side by opposite side. Okay, now you understood, I think, or else repeat it again and again. Draw a triangle for each and everything. You draw a triangle and represent again and again. It will be very easy to remember. See, adjacent side by opposite represents the cotangent. Now let us see about what is SINE, sine A. How to pronounce that and what is that? SINE, sine A. We are going to represent with SIN, but we are not supposed to tell as sin A. It is sine A. Now, the symbol sine A is equal to an abbreviation for the sine of angle A. It is not that sine A means sine is something, A is something. No, both are interrelated. That means sine of angle A. Understood? Next, sine A is not equal to product of sine and A. That means in the previous year you will be having A into B. That means A into AB means A into B. That means A is a number, B is a number, you can multiply it. Here it is not like that. Sine is not a variable, it is a function on angle A. Okay, that means sine is something working with angle A. It cannot be separated. Okay, next one. Sine separated from A has no meaning. That means sine is a function, so I can write sine. Sine is equal to opposite by hypotenuse. No, this is wrong. Cos is equal to adjacent by hypotenuse. Wrong. The function will never work without an angle. A function and the angle should be together, then only it will show some meaning, or else it's meaningless. Next, similarly we can tell about cos also. It is not a product of cos into A, it is a function cos on A. Similarly, interpretation follows for other trigonometric ratios, for tan, for secant, for cosecant, for cotangent also. Okay, now these are all the basics. Please repeat the basics for at least for 3 times, then you will be understanding the concept. If you understand very thorough with the concept, these are all very easy to do. Given, let us do the solvables. Given secant theta is equal to 13 by 12. Who is secant? Secant is the reciprocal of cos. That means secant is the reciprocal of cos theta. Okay. Who is cos theta? Cos theta is adjacent side by hypotenuse. So what we have to do? We have to find sine theta, cos theta, tan theta, cosecant theta, cot theta. That means they have given a value for secant. You find Sine, cos, tan, cosecant and cot. How? We know that all the persons sine, cos, tan, cosecant, secant and cotangent all are interrelated with the sides of the triangle. Is it right? That means all these persons are rounding behind the adjacent side, opposite side and hypotenuse. Right? This triangle is a right angled triangle. If I have two sides, I can get the third side with the help of Pythagoras theorem. Is it right? Here I have two sides. I don't know which side is this, but I have two sides. Now I have to represent it in a triangle. Then I have to find the other side, last side. So given secant theta is equal to hypotenuse by adjacent, right? That means that here it is given as 13 by 12. Here you have written as 13k by 12k. It's just a multiplication of constant. That means if it is 13 by 12 means it may be some other number. It may be 13 into 1 by 12 into 1. It may be 13 into 2 by 12 into 2, so that 2 gets cancelled. 2 get cancelled and it becomes the last number is 13 by 12. That is why we are representing it as 13k by 12k. Let us have a triangle. Okay, let us have a triangle PQR. In that secant theta. So where we are going to keep the theta? Here. Why? Why I am keeping the theta there? Because I know that 13 is the hypotenuse and they are relating with the secant. Secant is equal to hypotenuse by adjacent. Who is adjacent to theta? 12. Right? If I keep the theta here, this is my adjacent. 12 is not there. Right? So that is why I have kept the theta there. Now, let us see. PQ is equal to adjacent because theta is the adjacent side. Secant is equal to hypotenuse by adjacent. Okay, that is why where is 12? That is adjacent. Next, opposite to the 90 degree is 13. So that is hypotenuse. If I have both the sides, I can find the last side with the help of Pythagoras theorem. PQ is equal to adjacent side, PR is equal to hypotenuse and QR is equal to opposite side. Okay. Next, we are going to find the QR. How? By using the Pythagoras theorem. In the triangle PQR, we have, in a triangle means Pythagoras theorem, how it works? Square of the hypotenuse is equal to sum of the square of the other two sides. Right? Now only we saw that PR is the hypotenuse. Then we know PR, we know PQ, we need QR. So keep QR one side and other things other side. That means unknown one side, known one side. We get QR is equal to square root, and I think you know how to do this. QR is equal to square root of PR square minus PQ square. And now I am substituting the values. I will get 5k. Let us see our triangle. So PR is equal to 13, PQ is equal to 12 and last QR is equal to 5. I think you understood how we got the 5 using the Pythagoras theorem. Now I have all the values now. Now I can write all the angles, that means all the ratios. Sine I can write. Sine means opposite side by hypotenuse. Sine means opposite by hypotenuse. Cos means adjacent by hypotenuse. Tan, opposite by adjacent. Right? If I see the triangle, I have to tell all the ratios on the basis of the given angle. Be clear with that. Okay. Now let us see. PQ is equal to 12. PR is equal to 13. QR is equal to 5. Now we have in a triangle. Now write sine theta is equal to opposite by hypotenuse. So it is 5 by 3. Opposite by hypotenuse. Opposite by hypotenuse. The same reciprocal is cosecant. Cosecant is reciprocal, 13 by 5. Next, cos is equal to 12 by 13. That means adjacent by hypotenuse. Secant is ulta of that, 13 by 12. That is a mistake. Please correct it. Next, tan. Tan theta is opposite by adjacent, 5 by 12. So, its cot will be reciprocal, 12 by 5. Okay. Next one. That's all the sum we finished. Next, little bit tricky, but this is also very easy. If angle B and angle Q are acute angles such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. That means if sine B is equal to sine Q, then angle B is equal to angle Q. That is what we are going to prove here. So let us see. Let us consider two triangles, because this sine B belongs to separate triangle and this sine Q belongs to separate triangle. So let us have two triangles. Okay, so we have ABC triangle and PQR triangle. In this, they are telling the sine value of B is equal to sine value of Q. So I have to tell that B and Q are equal. Sine B, that means sine, opposite, so opposite by hypotenuse. So who is opposite here? AC. Who is hypotenuse here? AB. Right? Here, sine. So here it is. Who is opposite? PR. Who is hypotenuse? PQ. So right? So let us see. Sine B is equal to AC by AB. So opposite AC, hypotenuse AB. Same thing, sine Q is equal to PR by PQ. Now, here P is little bit. So here they have given sine B is equal to sine Q, right? I got the value. Sine B is equal to AC by AB. Sine Q is equal to PR by PQ. I am equating it to a constant K. Then what it will happen? I can write AC is equal to KAB. That means I am comparing first to the last. Next I can write PR is equal to KPQ. Right? Let us see. By Pythagoras theorem, what I want the last side. I have compared these two. I want the last one. So I am going to get BC. So I have AC and AB compared already. I want who? BC. So how I can find the BC? By Pythagoras theorem. That means BC is equal to root of hypotenuse square minus opposite side square. Right? AB square minus AC square. Next, QR is equal to root of hypotenuse PQ square minus PR square. Right? PQ square minus PR square. Next. Now what I am going to do is divide these two. BC by QR. Divide it. Divide BC by PQR. Now write the value of BC and QR. Okay. Now next what I am going to do is AB minus AC, how I am going to change as K square PQ and K square PR. How I am writing this? AB as K square PQ. AB, PQ, both are same. Right? See here. AC is equal to AC by AB is equal to PR, which is equal to PQ. That means KPQ. I am bringing one that side. Okay. Now next, if I compare that also, as previously I said, AC is equal to PR is equal to oppositely cross K AB square, right? Get it carefully. AB square. What I am doing is AB square. For AB square, what I am doing, PQ square, I am changing that as KPQ square. For AC square, I am changing it as KPR square. Okay, just by comparing it, that's all. Next, here K square, root of K square PQ square minus K square PR square. So in this K square is common. Take it out. What will happen? K square, root of K square, what it will become? It will become K, right? That is what happened here. So it becomes PQ square minus PR square divided by root of QR value is PQ square minus PR square gets cancelled. So what is my value? This is equal to K. I think you understood this. Okay. So now I have BC by QR is equal to K. Already my AC by AB, PR by PQ is equal to K. Now I got that BC by QR is also equal to K. That means as per triangle similarity, if two triangles are there, then their sides I can write in the ratios, then the two triangles are similar. If two triangles are similar, I can tell that angles are equal. As you studied in your 9th standard congruence and all, the same thing but in a different way. There you will equate the sides. Here the sides will be in ratio. Here the sides will be in ratio. If two triangles are there and I can able to write the sides in ratio and all are equal, then I can tell that two triangles are similar. On the basis of similar, my angles are equal. Sorry, my angles are equal. That is all. Okay. So that is what we are going to see here. AC by AB is equal to PR by PQ, which is equal to K, which is equal to BC by QR. That is what we solved now. Since on the basis of this triangle similarity, triangle ACB and PQR are similar. How they are similar? Because their sides are in the ratio and they are equal to each other. So on the basis of similarity, angles are equal. This is a very important sum for your 2 mark. Just be clarified with that. Hence we proved. Now the next one. If 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. So what they are telling? 3 cot A is equal to 4. Okay, so we are going to give a triangle. First we are going to take a triangle and we are going to compare that. Okay, so now they have given an angle A. Let us have angle A. Okay, next they have given 3 cot A. I know that cot is equal to reciprocal of tan, right? Cot is equal to reciprocal of, sorry, I must not write like this. Cot A is equal to reciprocal of tan A, right? What is the value of tan A? Opposite by hypotenuse. So 1 by opposite by, sorry, adjacent. See, we have to be very clear with that. Tan A is equal to opposite by adjacent. I think you know the basic of our division. A by B by C becomes AC by B. A by B divided by C by D becomes AD by BC. These two, repeat it again and hear it clearly. Okay, now let us have cot A is equal to 1 by tan A, which is equal to 1 by opposite side by adjacent side. What will happen? Adjacent will go to top. That is what we have written here. Given that 3 cot A is equal to 4. So what happens? 3 comes down. So what it will become? Cot A is equal to 4 by 3. Now what is my cot A? Cot A is adjacent by opposite side. Now if this is my angle, who is my adjacent? Here. Who is my opposite? So what I have to find the third side? I have to find the hypotenuse. How will I find the hypotenuse? By the Pythagoras theorem. That is what we did here. We found the hypotenuse using the Pythagoras theorem. How? Hypotenuse square is equal to sum of the square of the other two sides. So other two sides are BC square and AB square. Add it. So I will get 25k square. So it becomes 5k. So if this is 4, this is 3 and this will be 5. I think you learnt this as a Pythagoras triplets in your 8th standard. So now we have all the 3 sides. If we have all the 3 sides, easily I can write sine, cos, cot, everything I can write. So 1 minus tan square A by 1 plus tan square A. Now what is tan? Tan is opposite by adjacent. Now who is opposite here? Where is my angle A? Here it is. So my opposite is 3. My adjacent is 4. So tan A is equal to, my tan A is equal to opposite. TOA is equal to 3x by 4x. X cancel. So it becomes 3 by 4. Okay, that is what we have written here. Tan is equal to 3 by 4. Tan square A is equal to 3 by 4 the whole square. So hereafter it is just a calculation only. Next, 3 square, 4 square. So it becomes 1 minus 9 by 16 divided by 1 plus 9 by 16. Next step, we are going to take the LCM of it. So it becomes 16 minus 9 by 16 divided by 16 plus 9 by 16. What I said already, A by B divided by C by D becomes AD by BC. Okay, so that is what here happened. Cancelled. Okay, so what we get? 16 minus 9 by 16 plus 9. So we got the answer as 7 by 25. The first value we got. Now we have to compare with the right hand side. We started with the left hand side. We have to compare with the right hand side. Okay, so let us see for the right hand side. What is the right hand side? Cos square A minus sin square A. What is cos? Cos is adjacent side by hypotenuse. Who is the adjacent side here? Who is the adjacent? This is the angle, means 4 is the adjacent and 3 is the hypotenuse. 3 is the opposite side. Sine adjacent by hypotenuse. Sine opposite by hypotenuse. Just next, what are we going to do? Just calculate it. 4 square by 5 square, 16 by 25. 3 square by 5 square, 9 by 25. LCM, subtraction, we got the answer. For the right hand also we are getting 7 by 25. For left hand also we are getting 7 by 25. We got the answer. These are very important but also very easy 1 mark sum. State whether the following are true or false. The value of tan A is always less than 1. Is it true? Tan A, what is tan A? Let us see how. What is tan A? If I have an angle A here, tan A is opposite by adjacent, right? Always my opposite will be greater than adjacent. Not possible. There is a possibility that either opposite can be greater or adjacent can be greater. So here what they are telling, tan A is always less than A. When you will get less than, that means when my opposite is always less than adjacent. Is it possible that we have to take only that type of triangle? No, we have to take a triangle who have a 90 degree. Only that is the condition. It is not a condition that you have to take opposite side less than adjacent. So this line, this statement is false. Tan A is opposite by adjacent because opposite side may be greater than adjacent side. That it's not the thing that you have to take opposite side less than adjacent side only. There is a possibility it may be greater. Okay, next one. State whether the following, same continuous only. Let us see the next one. Secant A is equal to 12 by 5 for some value of angle A. What is secant? Secant is equal to 1 by cos A. What is cos A? Which is equal to adjacent by hypotenuse. That means hypotenuse by adjacent. Now my hypotenuse will be greater than both the opposite and adjacent, right? Is it true here? My hypotenuse is bigger, my adjacent is smaller, right? So this is true. Do you understood how to compare? Because secant is equal to hypotenuse by adjacent, and we know that hypotenuse is always greater than the adjacent. Now how are you telling that this is the biggest? Try with the help of Pythagoras. You will get the answer, right? Next. Sin A is equal to 4 by 3. Is it possible? What is the value of sin A? Opposite by hypotenuse. Just now we told that hypotenuse should be greater than both the sides. Here it is given 3 here. 4 is bigger than 3. So it is not possible that an opposite side is greater than hypotenuse. So this statement is false. False because sin A is opposite by hypotenuse. We know that hypotenuse is the always greater than opposite side. Okay, so on the basis of that, this statement is false. Let us see the next. Cos A is the abbreviation used for cosecant of angle A. Is it right? Here also cos is there. Here also cos is there, right? No. Cos A is cosine. Cosine A. Cos and cosecant is not related. Cosecant and cosec is related. You have to be very careful with this. So this statement is false because cos A is used to refer for cosine of angle A. Next. Cot A. Cot A is a product of cot and A. Is it true? Cot is a function on angle A. It is not a product of angle A. So this statement is yes, false. Cot is used for the cotangent of angle A. It is not a product of angle A. So here we finish our session and this is our assignment. Assignment is very easy. So as if we did in the second sum, and it's very easy to find. Just apply the Pythagoras theorem, get the last side and you will get all the sides. Write all the values, sine, cos, tan, cosecant, secant, cot. For each and everything it's a side so that you will remember again and again. Okay, so whatever the sums, for both the sums you write all the ratios. It will be helpful to remember your basics. By this we end our session. Thank you. Sai Ram.